Hey, hello guys. So today's stream will be about me starting game development. I just downloaded Godot. Haven't even opened it, but this is how I meant to be starting off with it. Let's see. Because we want to start a new project here. Okay. Let's see. I think we have to create a new folder for it. Okay. What do we have here? Render, supports desktop platforms only, advanced 3D graphics available. I think we're going with the best one. Okay, let's create a project. Yeah, so I literally haven't even touched this engine yet. Did some fiddling around with Unreal, but yeah, nothing else. Let's see. Get our basic movement here. Right click, we can bend the cam around. Okay, with the middle mouse button or scroller we can just rotate over the point of view. We can select things with the left click. Okay, got that. Yeah, so this will be a 3D screen. Okay, let's see what this 3D node can do. First thing I would like to do is to just place an object in there. Just, I don't know, box. Let's just check out our object or options. So yeah, I haven't even delved into a tutorial. Just want to figure this thing out by myself first. Shouldn't be that difficult. We can switch the view from this menu here. Interesting. Okay. Switched back to the perspective mode. Okay, we already got the basics of the camera movement here. Okay, I think we can use this online documentation. Sure, let's check it out. Hey, get some bullets. the solution for the headphone problem. Oops. Okay then. We need a solution for this headphone problem. I'm just going to do this in stream. It's microphone input. Only in one ear. Mic only in one ear. Okay. Let's see if we get a solution for this. So, as you said, you just right click on the gear of your audio source, advanced properties. I think it is one of the toggle boxes. Down mixed model. Need to check that. Ah, okay. Let's see. Actually, I may as well just show OBS as well, just so you guys can see what I'm doing here. So this is the microphone input, properties. What was that option? Audio source advanced properties. Okay. Now this should be it. How about now? Okay, great. Thanks, Ben. So now that that's solved, let's see what we can find in the Godot docs. Okay, introduction. Before you start, tutorials and resources released video tutorials contributed by the community. I'll just stick with the text. List of features, system requirements. The editor. Okay, not sure actually what to. Create new node. Perhaps this could be a way to add some objects here. I'm just going to open Unreal just to compare the two things. I think my PC can handle two engines at once. Especially the Godot isn't that resource heavy. Might as well just do them parallel. Let's see. Just create a new third person project. That should be the name.
Let's see. Basic stream platformer.
Basic platformer. Yeah, I will want to create a platformer game eventually. So, I already know how this works. So we got a template for this, some objects. If we start the game, we have a character to move around, jump around with. This is pretty advanced. This is all default, like it's part of the template. I haven't actually tried to do with these. I also have collision. Push the boxes here. Yeah. So it'd be great to achieve this in Godot too. Because Unreal is actually much more complex. But let's see. If we want to add a object here, we just have to find it in this menus. Up. I think I know this. I've been already following tutorials, that's how I progressed with Unreal Engine so far. Okay, we add in an actor. Not sure what this means. Maybe a playable character or... Okay, just redo this. Yeah, this is all for comparison, by the way. Shapes, cube, okay. Here's how we add a cube. Now we have a cube. Just place the cube here. Let's see what we can do with this. It has collision, so we can't go through it. Can we jump on it? It's a bit too high, maybe. Yeah, let's stop. Just checking out what can we do here. Yeah, we jumped on the box that we just placed. Actually, if we just add a few more boxes, we have a basic platformer gameplay. We just have to be clear how further we can jump. Yeah. Actually, it seems a bit more simpler to start out with Unreal like this. We get everything by default, the template. Let's just try this out. Yeah, really nice. Now, how can we achieve this in Godot? Okay, just saving this project. Now I want to figure out, we have to add some landscape or such. It's much more difficult because we don't get a basic level here. But overall, this is considered the simpler engine to start out with. Okay, I'm going to give in and check for some video tutorials. So, by the way, the big difference between Godot and Unreal is that Godot is open source. So what that means is you can just develop games with it and there's no royalty, no costs involved to them. Okay. This seems to be some basic. Let's read it. The series builds upon the introduction to Godot and will get you started with the editor and the engine. You will learn more about nodes and scenes code. Your first classes with GD script. Yeah, I heard about this. GD script is actually Godot's own language. It's, well, if you know what I'm talking about, it's a bit similar to Python or JavaScript. So use signals to make nodes communicate with one another and more. The following lesson are here to prepare you for your first 2D game. Actually, I want to see the 3D game tutorial. Okay. This step-by-step series, you will create your first complete 3D game with Godot. By the end of the series, you will have a simple yet finished project of your own, like the animated GIF below. This game will code here is similar to your first 2D game with a twist. You can now jump and your goal is to squash creeps. Oh, fine, you will learn to work with 3D coordinates and dynamic. Okay, let's just jump to the start. Setting up the game area. Prepare the Godot project with the 3D mounted sounds we'll use for this tutorial linked in the index page. Aha. So we have some assets, but I actually don't want to create this game, I just want some. But yeah, I will still need assets, I think. So box is not that difficult to create. Just open Blender. Use that to create assets, but for now I just want to make basic shapes and such. Something that we can use here. So not going to download these assets. In the import pop-up, enter the full path to freshly created directory. You can click the box. Yeah, so have to find that import menu first. Asset lib. Oh, we already got some basic assets here. Want something basic. Basically anything that we can put in the game and move around with. Yeah, so this is Blender. We already start out with a box. We should just export it. I'm not sure, but what form can we use this in the game. Okay. Still trying to figure out what can help us here. Maybe it might be better to just follow this tutorial along. Well, fine. First, we're going to set up game and let's get started by importing the start and setting up the game scene. We prepared the godot project with the 3D model sounds we'll use for this tutorial. Link in the index page if you haven't done so yet. Okay, fine. These are the sets. Okay. Download. Check. Where was I? Back to here. Once you download it, extract zipper archive on your computer. Open the Godot project manager and click the import button. Project manager, that's what we need. Project settings. Not exactly. Version control. Might as well just search for some Godot 3D platformer tutorial. Okay, this seems like
This project is from the
what we want. Introduction and setup. Yeah, they're explaining stuff here. Create root node. 3D scene. I found out this myself how to edit. And then okay, perhaps this was what I was searching for. This is adding a camera here. Okay, 3D camera. Sure, we can do that. Search for camera. This is it. Now we have a camera. And can we move this around? Yeah. Cool. So this will be our point of view, perhaps. Main scene has never been defined. Select one. You can change it later in project settings under application category. Yeah, let's go with the current. This for running it. Will I be able to see something? Perhaps we have to add lights as well. Yeah, leave that for a while. Let's just follow the tutorial, explaining stuff. Okay, what's in this menu? Most of the stuff I just want to find out by myself. Sound direction. Cool. Can't actually see much from here. Yeah, we can edit the sun. Add sun to... okay. Now we have a sun. How does it look when I want to run it? Still nothing. Or should we see something? Yeah, whatever. Let's move on. Next step. Add environment. Oh. Okay, sure. Did we edit it? Not yet. Sky color. Ah, we're changing it right now. Let's go with this brown color. We have the world environment now. Direction light 3D. Yeah, we can move this stuff around too. There's the sun. Cool. So what else? Run current scene. Yeah, we can actually see stuff here. Guess it's from the camera's perspective. And does it update or what if we... Let's see, how do we rotate the camera? Here. Wait. Move this close. Aha. Okay. You see our skin changing as we move the camera. Cool. So what else can we make? Yeah, we just save the scene here. Yeah, that's what I was doing, creating simple shapes. Now that's what I was stuck with actually. But it's good to know that we need a camera as well. Good time to the floor to give us something to look at. Yeah, not a bad idea. Meshing stance 3D. Cool. Let's just check out this menu. Mesh instance 3D. Mesh instance, yeah, mesh. Okay, let's check this out. Okay, what's this? Okay. How can we use this? Maybe it will be actually
where we can
useful to
give
listen what
primitive
it
shapes
says.
like box, sphere, and cylinder. To select a mesh for this Mesh Instance 3D, click on the word empty next to the word mesh. Then select New Plane Mesh from this list to create.
Okay, we'll do that. Mesh. put it right where the camera is. So will we expand this or how do we use
8 hour
this?
floor mesh. This plane is then visible in the editor's viewport as a 2 meter by 2 meter grey square. Gestures down to a view below the floor. Drag the mouse down to rotate the view back up and you can see the floor again. Size now holds a plane mesh object that we can customize. It is in the inspector. Godot has objects we can expand like only has a mesh, it would also have a depth property. We can set the floor's size with the mesh's size property. Set the size property's x and y values to 10 meters by 10 meters. You will see the mesh updates in real time in the viewport.
Okay, cool. Just I'm worried about forgetting this when I would want to do it by myself. So here's how we can edit this. Let's set it to 50 meters. Okay. It might not be completely parallel to the ground here. Let's see how we can rotate it back. Is there setting for snapping into the right angle? Still looks a bit silly. Or is it parallel to the ground now? Oh, what am I speaking? This is the ground. Okay, let's stay with this.
While hovering the mouse over the viewport, you can scroll the mouse wheel up and down to now we will not be able to see check or P to toggle the camera preview. This will show what the camera can see directly in the viewport.
But there's that few thing
to update the camera's position and orientation, we can use the 3D gizmo. This is a handy tool available directly in the viewport for whatever node we have selected in the scene tree. Select the camera 3D node in the scene tree, arcs in green, indicating mouse drag in the axis. Anything we grab the position and rotation property.
Actually, let's just try this out, looking from the camera's perspective. So this is the... Are we moving the camera now? Or... Okay, just bring this back. I only want to move the... Wait, I think I have screwed something up here.
Up down. You should see the position.
Oh, yeah. I made a mesh instance. Attached to the camera. Right, now it's with the direction right. Okay. I guess that's how we move things by group. So here's our camera. Know how to move this stuff around. This isn't a big deal. What was this error message here? Oh, it's long. 10 minutes looks alright now. Our plane mesh moves independently from the camera. I guess that's good.
Y property is something other than 0 as you changed its position with the gizmo. I will manually position with F6 and entering 2.
Wait, was there some rotation?
Now when running the
Okay. Because we need the mesh to be 90 degrees to the ground or something like that. Where are the transform properties? Oh, got it. Rotation. Yeah, that's how we rotate. Yes, we want to set it to 0 degree. Okay, that's that.
current scene with F6 or the play current scene button, you should see the same. Godot offers many powerful graphical options to control the appearance of what you create, and it is best to understand these settings in the top bar on the lens, as well as a bunch of useful customizations. In the tree on the left, you will see a variety of tabs for options relating to your project, under the display drop-down side of the page.
Yeah, just want to know the...
I am using a 1920 by 1080 monitor.
That's why I would prefer to read it in a guide, because the most important things are highlighted here.
So to best fit, I'm going to set my viewport width and heights to the same dimensions. I also want my game to take up the full...
This is actually pretty useful. We want the game view to be full HD at least. Project settings, display window. Yeah, like that. Let's stay with windowed mode. Initial position type. Center of prime scene. Resizable on. Stretch. VSync enabled. Okay, I have no problem with these settings. It will be alright.
screen based.
Let's see if something else.
The stretch mode and resizable options on the screen are often important in letting you make the screen have fixed dimensions and stretching pixels to keep the viewport scale the same on different monitors. The next important setting to cover is anti-aliasing options. Under the rendering subheading, you can find and select the anti-aliasing tab. Anti-aliasing options help us avoid jagged, sharp contrast edges in our games. These options are all disabled by default for the best performance. Hovering over the names of options like MSA 3D will reveal a tooltip giving you more detail about the option. I'm going to set the multi-sample anti-aliasing MSAA 3D to 2 times. To keep this window streamlined, Godot 4 added a...
Thanks though.
an advanced setting.
Let's just check out the filter. Oh, this was the menu font. Ah, cool. We'll use that in the future.
Toggle in the top right. Clicking on this
Okay, anti-aliasing. I think I'll just leave this like that, or not. I don't expect any performance issues, so I just need to
toggle will reveal many more project settings that are worth scrolling and we can control the quality of our shadows. For the moment, we own and we don't have any other lights.
Shadow.
I will slightly improve the quality to soft medium. My guide on how to create a 3D platform.
Okay.
Now we have a simple level we can focus on getting our player character up and running.
Okay.
We may want to add the player to a variety of levels like this one, so we will make the player its own scene.
I may actually just create the basic human shape in Blender. Have some knowledge about that, some very basic, but I think I can figure out something.
In the top bar on the left, click the Scene drop-down and select New Scene. In the new window in the scene tree, select the Other Node option. When you select the Other Node option, the Create Scene. For our player character, 2 nodes are up for consideration. Rigid Body
a new scene.
3D and Character Body 3D. I am going to show you how to
Rigid Body
make of less precise control the Body 3D in the scene tree. Double-click on the node and rename it to Player, then hit Enter.
Okay, let's just do this for now. New scene, other node, and 3D rigid body. This is what teaches, right? Here. Player. Don't want to copy everything, right? He does, but
When you create a body node
just
in
want to
Godot,
get familiar with the basics first.
so we can see the body and a collision shape 3D. Add a mesh instance 3D as a child of the rigid body 3D we named Player. This node is how we will see our player. With the mesh instance 3D selected in the scene tree, look to the inspector on the Ruptual mesh from the list.
So this is how we can create the body for our player. Okay, let's just check again. I didn't
Ruptual
catch.
mesh. Click the selected in the
A new mesh
drop-down
instance,
and select
right, we already knew that. We're adding a child node and it will be a mesh instance. 3D mesh instance, right. Yeah. We could actually... I think we just take a break from Godot and let's just create a basic human shape out of this box here. See if I can still... And the music stopped. Actually just running a playlist of non-copyrighted music. Just so you can hear something else besides my babbling. So, might have forgotten quite a bit. Okay, trying to remember edit mode. Okay. So let's see how we do this. Add cube, extrude region. We want to first select a region, right? Loop cut. Okay. This is good. I just want to create some limbs for this box. That's how we start out. But I'm not sure how to select it actually. Yeah, when I said in the beginning that I'm just starting out with this, I really meant it. select all. Okay, it's a solution. Now we can scale it and let's make it more leaner. Yeah, this will be the body. Okay, some progress. Now how can we select just one edge of it? Well, not edge, the face. I want to select the face. Clear, smooth verticals, randomized verticals. Try to remember how I do this here. Maybe stuck here. I want to select just one part of the box. Okay, let's look it up. Blender, select, face. To select parts of a mesh face, you have to switch to face select mode. This by clicking the button shown above. Okay. This is the official box. Docs. Faces. Face select mode activity. Ah, cool. So back to Blender. Okay, where's that? Face select mode. Control tab. We have a menu here. So, edit mode. Scout mode. And this is just the editor choices. Hotkey Alt R and B. Right mouse button, yeah. Hey, I'm doing it. But this is for the edges. Or is it not? Alt and right mouse button. Do we just select the... Wait. What are we editing here? Okay. This could be actually useful, but I want to make it symmetrical. Okay. I just go with this too. Blender, Symmetry. Symmetry tool. Good. A new mesh, snap to symmetry. Okay. How can we find that menu point? In the edit mode. Mesh. Oh, yeah. Snap to symmetry. Got it. So now when we do something here. Okay, didn't do anything. Okay, I think we switched modes by accident. Back to edit. So we create this. If we cut out the part of the box. Hey, changed modes again? Wait, where did the... Can we just move back? Okay, I think I'm just going to open a new project here. Yeah. Just redo what we did earlier. Make the box more of a human torso size. Okay. And now we want to edit it. And I only want to select the face. Okay, we are selecting stuff. Not sure actually what I'm selecting. Face select mode activated. Still not finding it. Select. Box select, circle surface select. Wait, up this. This is it. Okay. We selected the face. Now if we do this. Okay. I want to... Let's see. Inset face. Okay, this will be the neck. Smaller. Come on. Can do it. Okay. That will be the neck. Now we extrude it. What does this do? Ah. Okay, this is a bit better. Select this shape, extrude. This face. Select this here, I want it to be symmetrical. Wait, how about change modes again, I think. Back to edit mode, mesh, snap to symmetry. That didn't snap. No problem. Let's go back, select these two faces. I'll actually select all of the faces at the side. Now we extrude. Okay, not up, I want it to go. Okay, that's a bit weird. How about this? Not good either. Let's actually try to make limbs. It would be nice to have this a bit upward. Back to face it. Symmetry. Now there we go. Wait. Not quite right, but wait. Yeah. Getting lost in the many points here. And this will be symmetrical. Wait. What kind of symmetry is this? This is not the right angle. Okay, weird. They didn't keep switching the sculpting instead of the symmetry settings. Mesh. Okay, let's just check the docs again. Snaps do lets you snap mesh verticals to their mirrored neighbors. This one will do meshing. This can be good. Same tries to. How does this work? Hey, mirror. Mesh mirror desired axis. So okay. We want to create a limb here. This looks ugly for the moment. Let's mesh and where's the mirror? This will be on the z-axis maybe. Oh. You might want to select the whole thing here. Select all. And let's see. Mirror on the Z. This just turned it around. What I want to do is edit it symmetrically. Okay, let's just change this back. Did a whole bunch of random edits here that I'm not sure of anymore. Okay, let's go back to object mode and shape it a bit more. Okay, this is how I want. Edit mode. Not that. Okay, like this. Extend it. Okay. And now extend it again. And this will be the head. So this face doesn't go the right way. But this is just the basic transform tool. What does it do if I want to move it? Axis of symmetry. So the mirroring tool doesn't really work out like I want to. Mesh symmetrize. But if I do this, then maybe if I select it in object mode. No. Now it only that one face is symmetrical. Okay, but we got something different this time. What if I select all the faces here? And now I'm selecting symmetries. Okay, now it's symmetrical, but I think we're missing some faces there. How did this happen? Somewhere along the way they got removed. Okay, let's symmetrize again. Now the faces are gone. Okay, just select more of them. Keep clicking to this. Back to edit. Okay. All face on left side selected. isn't it? No, what the hell happened to the body? Okay. I just click select all and let's see what happens now. Now it's symmetrical. Okay. Now let's do those arms. Where do we want it? Let's put it there. Oh, come on. So that we created that one line there. Okay, we extend this, or not right now? Not yet, okay. We'll get there eventually. Okay, let's just extend it. Can we make this section a bit cleaner? Just want to scale it differently. Like so. Okay, but I will select more of these faces. Perhaps the whole body here, except the head. Okay, come on now. Okay. Redo. Maybe just the arms. I will shrink it. Oh. Okay. And this looks like an arm shape. What happens now if I add symmetry? Nice. Get a little T-pose there. Now what I want to separate the legs here. Let's see how we can do that. Okay. Move them a bit. Goes with the whole. There should be a way to separate these two. It rotates as a whole. Okay, fine, we need that. Actually, we want to shrink this a bit. This portion here. It doesn't seem to be symmetrical anymore at the bottom. Oh yeah, and also might just scale down this bit. Lower side. Yeah, like that. Starting to get something of a humanoid shape here. Yeah, I just want to give them a little bit of a rounded look for the head. scaling here. Perhaps. Let's try to set this with rotate. Not exactly symmetric. Oh, perhaps just the edge. Let's select this. And extend it forward. Okay, now on the back side too. Okay. Not bad. Let's just select all again and make sure that we still have the symmetry here. Okay. Very nice. I want the legs to be... Oh, actually, that's how I do the legs. Oh, this a bit inward. And now we grow out its legs. It stays connected together. Not quite what I intended. There was just one side. Right there. This is the leg. Now let's do some symmetry. It got legs. We achieved legs. Okay. This seems to be a bit... This to be straight. This portion. How do we make it a bit more vertical? This isn't it. Maybe we have to select the whole back side here. Okay, it's looking a bit silly. Just want to scale it a bit, or not scaling, just move. Okay. Oops. Okay. I give it a little bit of weight here. Oops. Select this one. No. Just select this portion. Yeah, that's too much. Fine. Extend here. Yeah. Starting to look... It's kind of like a robot. But that's fine. Let's make it symmetrical again. Yep. A is for select all. And now symmetries. Okay, symmetrical again. I think let's select these two verticals, and maybe scaling is what we need here. Not to move it this way. Let's see. Now we just move these two edges together, closer. Then that inner edge a bit inside. Does this have a proper humanoid shape right now? Let's say this is our model. Or I mean, I might do some final edits after, but still not quite sure. Supposed to be symmetrical now. Object mode. Actually, I think not sure, but the knees are a bit like, let's say this will be the knees. Need the legs to be a bit longer. This portion. I don't want to submit it all again. I can't want this too much. Why does it select parts that I don't want to? Okay, maybe if I let's see. I just extend this. No, can't do it without the other parts of the leg. Bottom side. And now we move it down. Perhaps just not quite right. Shade smooth. Whatever, let's just save this. Oh, it's untitled. Very right. Whatever, it will be untitled for now. I want to check how to import something from Blender. It has to be the trash mesh obj. Get an object type here. Let's just double check here and Google it. So what do I want? Import Blender model to Godot. Ah, this is a short one. Okay.
In Godot 4.
So
Under 3 port format. And what's great about this model to FBX or some other model, the changes automatically logic set Blender 3 or greater for path here.
import.
Mine looks like this. Note that you need Blender 3.0 or greater for the short and drag like project. I just have my blend file. No.
What was the menu for that? I think I'm doing it. So, do we have a... Hold on. File recent. Oh, this is Blender. Oh, but we also need a file path from Blender. Okay, let's find it. check
This in Godot 4, model to FBX or some other model export format. And what's great about this is when we edit our model in Blender, the changes automatically transfer to Godot.
how we do
To set this up, first go to Project Settings, File System, Import.
project settings. System. Blender enabled. Oh, that's nice. Apart from that,
Make sure Blender is enabled.
it
Make
is.
sure that you have advanced settings enabled, otherwise you won't see this setting. Then go to Editor, Editor Settings, Blender 3 Path, and add your Blender 3 path here. Mine looks like this, Blender 3 Path setting. Then go to Editor, Editor Settings, Blender 3 Path, and add your
Editor. Okay. Editor settings. Blender. File system import. Blender thing. Back. Okay, how do we set this
your
up?
Blender 3 path here. Mine looks like this.
Okay. I think I have it copied. Yeah, this is it. Editor must be restarted for changes to take effect. Okay.
Note that you need Blender 3.0 or greater for this. I was able to find my Blender 3 path by searching for it. Right click here and here's the folder.
Oh,
Clicking on
wait.
properties and then here's the target right here and here's the folder.
Is this the path of the application? Wait, it paused again. Does it do something about it pausing my music?
New,
Back
but on
to
the
this.
with the mesh
This
instance.
is the other tutorial.
Okay. Clicking on properties and then here's the target right here and here's the
Target.
folder.
Yes.
And drag them directly below these and then here's the target right here and here.
Okay, so which part of the... And therefore... No, not this. Come on. But this is what this is supposed to be, the blender.xf path, or
Here's the folder.
the folder which contains the models I have.
Now you should be able to add Blender files to your project, like this one here, and drag them directly into your scene like this. Note that if you're like this one here,
Cool. So if I say this and yeah, this isn't the... What am I searching for? Write this in and editor must be restarted first. Okay, where am I? This is the first scene I made. Oh, perhaps the... wasn't saved. Let's recreate the same. Opposite 3D, widget body, MVP player. Oh, and also I did a mesh to it, mesh instance. Okay, let's just get the pilot of this. Titled. Will this work? Okay, I lost a bit here. No
Here,
worries.
folder. Now you should properties.
I think the pilot is set right here. The music is too intense. Wait, let's just save the scene. Clear that. Okay. Clear. Need an editor path. Benders. Is it at the bender thing? How old is this video?
Properties, and then
Just 7 months. They have godot floor. Set up an import.
We're going to jump right into it.
10
I'm working
minutes.
within your editor when you do that.
And
That's
just a
totally
few
okay. So the
clicks.
file, again, looking at file system, import, and then Blender right here. Manage
See.
folder under Blender Foundation and then Blender 3 point whatever. You select that.
Yeah, let's just get the path again. My location. Is it supposed to work with Blender 4 as well? Why doesn't it change? Okay, I need the full file path. Program files, Blender. This is. Yeah, this is it. Okay. Okay, we got everything saved. We start. And now what?
That current folder is working. Now, a good way to do this is to make sure you have Blender open before you
This actually
open
got
your
it
godot
for
4.
Blender.
and then to your project, like this one here, and drag them directly into your.
All done.
Scene like blend,
did it
and then
learn that?
here's the target right here, and here's the folder. Now you should be able to add Blender files to your project, like this one here, and drag them directly into your scene like this.
I have a feeling we might have skipped a few steps there. This is the... Should we try to save it to there, that path? I have to find it first. I find this thing to be crucial to learn how do we import things, because I will be making other models in Blender. What's this file system here? How do we find it? What's the full path?
Note that if your model uses one here, it's a folder. Now you're clicking on properties.
Step here. But when I search for Blender 4 and Godot, and it gives me Godot 4 and Blender. What's this? Godot 4 works with Blender 4.0. Just if anyone wonders, you can use a Blender for installation, although Godot officially supports Blender 3.x. Okay, so it shouldn't be an issue that I have Blender for.
And then here's the target right here, and here's the folder.
Is it the full
It's a short
path, or?
opening file location. Right clicking on this, which is the shortcut, clicking on properties, and path by searching for it. Right clicking, opening file location.
Yeah, that's file
Right clicking on
location.
this, which is the shortcut,
Properties.
clicking on properties, and then here's the target right here, and here's the folder.
But so not the full
Clicking on
path,
properties,
but
and then here's the target right here, and here's the folder.
folder of the sure. It's a file location. But this is where it is. So but this is just a shortcut. It's not right. Click over the file location. But this isn't the application, it's just a shortcut. This is the file location. This is the file path. But is it set correctly? Should not want to do this. So we copy this here. Again, editor settings, search for Blender, file system, import. Oh, this is our location. This is where Blender is. Where do we go deeper? Oh, this is where it's supposed to be. Select it. Perhaps restart. And now, how did this guy
Folder.
get the model?
Now you
right
should be
after?
property location. Right clicking on, here's the folder. Now you should be able to add Blender files to your project.
Add Blender files to project, but okay, perhaps he skipped that step. Open in File Manager. This is our preference. Okay, how about I just saved the Blender project there. I got the file location right. Which was it? Need a file path. Here it goes. And we name it layer.plan. Okay. Try importing assets. Here we go. Oh. Why is it so shiny? Looks weird. Okay, remove this mesh. We got the player here. What's with it? Why is it a light source? It's a bit weird. Maybe I just paint it. Okay, how do I paint it though? Missing textures. Okay, how does texture paint work? Is it not just the texture? Okay, shading. Want to make it less shiny? Roughness. Okay, let's just assume this. Okay, I'm not sure what this setting is, but Let's save it like this, see what happens. Yeah, I don't see any changes here. Also, there's supposed to be an option for smoothing edges. Under smooth edges. First, to make smooth shading looks less weird, you should have a normal auto smooth. This is where can I change the material. Unload back. Where that's supposed to be? Circle. Okay. This is the menu. How to smooth. Okay. What happens if I save it now? With the saved. Doesn't look any different. So
like this one here, and drag like mine does here, your image texture file also needs to be in your, in this case, I just have my blend file, no image texture on it. If you're finding yourself in this situation where your model's textured and import properly, you can go back to your Blender model, navigate to the image editor panel, click image, save as, and just save your image texture to the Godot project directory. So I'll click save as. I will then save my blend file to update this reference to my image texture and project directory. And just save your image texture to the save as, enter panel. Click.
I don't have a texture though. Or do I have it? Image editor. Might want to add texture first though. Or texture. This doesn't seem to be what I want to.
So you want some open,
I think
and once
that's-
you open, it'll open up this your file folders essentially in all different directions. Like that, and change this to the.
What if I want to paint it to a certain color? Okay, let's just leave this for now. Going back to the
3D selected in the scene tree, look to the inspector on the right. Click the mist. Often we'll want to create a matching collision shape.
collision shape.
To help with this, there is a contextual mesh drop-down at the top of the viewport we can use to generate a collision shape 3D. With the Mesh Instance 3D select,
How do I do this with my model? What's this? Notification. This node has no shape, so it can't collide anything with other object. Okay.
click the Mesh button at the top middle of the viewport. Then, from the drop-down, select Create Simplified Convex.
Simplified convex collision sibling. Can I wait for this? Okay, let's just do with what the tutorial wants us to do. Radiation. What do we do with this? Physics, material. Am I in the right place?
Place of Jabber's down and select New.
Mesh instance. Oh. What if I want my layer to be that? My mesh. Has to be an object. Perhaps if I export it to object here. Pair that obj. Embed light for material. Okay, now I can load it up. Okay, let's remove this. Hey! It doesn't have that silly light aura around it anymore. I like this one better. So now that we get it, How do we-
capsule mesh have a mesh instance 3D to generate. Click the mesh button at
Sure,
the
took a
top
while.
middle of the viewport. Then from the
So,
drop down,
smash.
select create.
Simplified complex collision sibling. Okay. Seems alright to me.
Create simplified convex collision sibling.
Yeah, it's convex, so
Now
doesn't have that inner band.
we have our collision shape, we can focus on setting up
Collision
our
shape.
rigid body 3D for use as a player character. Select the rigid body 3D player in the scene tree, and in the inspector, find the lock rotation property and enable it.
Lock rotation. Okay, but what does it do? Tell me.
Rigid bodies are often used.
I think we can find here. Lock. Rotation. Here.
as physics
That's
objects
good.
with great freedom of movement and rotation. We need to lock our player's rotation so the capsule does not tip over as our player walks around. Godot uses script files to give instructions to the objects in our games. We write these in the GD script language, a specialized lightweight scripting language.
We're going to do some script.
We will add a script to our player character that will listen to key presses.
Wait, I want to try this out. How does it look when we... Wait. Here's our... How does it look? Can't see anything. Oh, maybe we should have a camera here. Oh, whatever.
And use those to move the player in the corresponding direction.
Tutorial guy says.
Right-click on the rigid body 3D root of our scene, and from the drop-down menu, select the Attach Script option, which is an
Okay.
icon of a little scroll of paper and a green plus.
I should just pop up this video.
This will open a contextual window for creating a script file. We do not need to customize any of these options, so just click Create.
Don't ask, just do.
This will change our main screen for the first time. Instead of seeing the 3D
Alright.
viewport as usual, we can now see the script screen.
To the other side.
You can swap back and forth between these screens by clicking on the 3D button or the script button in the middle of the top bar as you need them.
Let's see.
Our script has a few lines that are important to us right now. The first lines of the script says extend, then the name of the node, in our case, extends rigid body 3D. This tells us the script is attached to a rigid body 3D node, and we can access all the properties and functions of a rigid body 3D in code. Two functions have been added to this script by default. The functions are defined with you can add for a specific task. They have a specific name and specific parameters.
I just want you to tell me things that I don't see.
Process is a virtual function. The delta is necessary for making changes appear the same. Process input to info can access from. If this up button is pressed, the get action strength function gives us a value of 1.0. Otherwise, it returns 0.0 and the player will not move. So now our variable input is either 1.0 if the up arrow is pressed, or 0.0 if it isn't. Fly central force is a function of the rigid body 3D itself. It lets us apply a force in a 3D direction. 3D directions are represented by the vector 3 object, and vector 3.forward gives us a vector 3 pointing forwards. The asterisk symbol means we are multiplying the velocity upwards. Then is a lot of this the scene drop down and select Save Scene. The Save Scene as prompt should automatically name the file save down in the scene tree to reopen that.
Okay, so the code for moving a character. Right. Just want to see the code again. So we try this in the process function. Input variable, which is input that get action string. Hurry up. Cool. And then apply central force. Yeah, so this gets our input that for our up button, get action strength. What we're doing here is with the input variable. This is basically the strength of our action. Tell declare here that the force of detection should be applied to forward movement. I don't know if this makes sense. It's borderline isn't for me. I guess we need the delta for time. We need to save it. Okay, just save it. Central force. Guess that means that the action comes from the center of our character movement. Okay.
Is held.
Let's move on.
To test this script, we need to save the scene. Scene.
I saved it.
The code is called player.scene. Click Save.
Yes.
Double-click on level.scene in the scene tree to reopen that scene. Then, in the top bar, click the 3D main screen button to return our view to 3D. Now we can add the player scene to the level. Click on the root of the level scene in the scene tree to select it. Right-click on level player scene 3 bar, click the 3D main screen button to return add the player scene to the level.
Explaining it so slow that I'm falling asleep.
Click on the root of the level scene in the scene tree to select it. Right-click
Yeah, so
click on player.scene down in the file system and select Instantiate from the drop-down menu.
okay, got it. I think I'm renaming this to the main scene. It's going to be main scene. Let's go. Can we rename the file as well? Okay, I think I have to restart the music again. Incredible. Just leave the Blender tutorials. How much clutter? Don't have. Just don't like to have too much tabs open. It confuses me. So, where do we? Okay, here are the player scene. Select instantiate. Go back to the 3D environment. And our guy is here. Let's see what the camera sees. Oh. Boy just fall off the world. It's unfortunate. Guess we will be setting the collision with the world plane next.
Instantiating a scene creates a copy of that scene as a child of the currently selected node.
It created.
Now the player will be visible in the level 3D and set the positions the transform section and expand it. Set the positions Y value to 2 to raise the player above the floor and the Z value to -2 so the player is in front of the camera. If we run the scene now, our player will fall straight through the floor. This is because our floor is just a mesh and not a physics body like the player. In the level scene, select the floor mesh instance 3D, then at the top of the viewport, click the mesh context.
Collider too? Yes, we're doing it. Simplified convex collision sibling, or do we do another
button, and select Create Tri-Mesh Static Body from the drop-down menu. This creates a static body 3D as a child of the mesh instance 3D, with a collision shape matching the mesh itself.
Mesh instance, everybody, 3D. Collision shape for this one too. What happens now? Whoa. Touch the ground. Amazing.
A static body 3D is another kind of physics body Godot uses that is intended for objects that do not move. Now, if we run the scene with the Play Current Scene button in the top bar, when the game runs, the player will fall to the floor and stay there. If we push the up arrow on the keyboard, the player should then hurl themselves off of the platform.
Wait. Can we do that as well? Oh, we're moving. Oh shit. I guess we can set up the movement ourselves. This is something we can do by ourselves. So input actions, strength. Let's see. It's the forward movement with the up arrow. Guess we create a few copy of this line. With UI. Let's see. Left. Right and down. Rename the variables. Up input. Left input. Right input and down input. Okay. Copy this line a few times. this as well. Up. Shit. No, don't copy that. We need this here. Up, left, right, down. Or just put the up and down next to each other. Looks more orderly. And so up is forward, down is backward. Oh wait, how does it go? Forward, back. I think this is it. Left. And then right. Alright. Save. Now let's see how the magic happens. Wait, is it this live? We are moving! We achieved movement. Of course we don't have animations with this, and also we can't move the camera, we didn't set anything for it. This thing is actually working. It's a bit weird, but I actually got something working here. Okay. Let's check if we can get a jump action to jumping here. Let's do this with space. And what is the space button? Space. This is all the backspace. What kind of buttons can we have? Anyway, select backspace. I think I just look this up. Godot space button. Space bar as an input, okay. It's the UI select button, okay. Now we apply force. Guess this is the force of the moment. And it is space input and it's going up. Let's see, set the strength to double the amount of the others. Okay, let's just check out what does this do. Come on, give me something. Hey, we're jumping. Okay, moving. Jump. Oh. Fly. Oh, because as long as we press space, we get that movement. Actually, just fire out. Oh. Oh, slow down. Hey, come back. Okay, we're back. Great stuff. Okay, let's see if the tutorial can give us any more.
Most modern games do not use arrow keys for movement.
Yeah, I guess so. Let's see if I can find it out myself. Just to be able to skip this section. W. UI. Guess that would be another kind of.
Instead opting for the W, A, S and D keys.
Of course I
To
could.
set this up, we need to configure input events for the project.
Wait.
Godot lets you access every input the user makes, but for convenience, multiple input device support multiple inputs, and click then at the top of
Project settings.
the UI up event we listen to for movement is defined here, or to see all the predefined actions you can listen to.
Oh,
In the Add New Action bar at the top, type move_forward and hit Enter, or click the Add button. This creates an input event called Move Forward that we can attach inputs to. On the right of the Move Forward input
okay, this is new.
in this window, you can either select for the event you want, and that it detected a input you want, and now whenever the W key is pressed, the Move Forward event will trigger, which we can look up by name. Repeat the process for Move Left with the A key.
So project settings and input map. Okay, we can do that. Adding actions. Move forward. And we assign it to W. Physical key code. Ah, that's it. For the other actions as well. Another action is move back. And it will be ASCII. Move left. Next one. Edit with the A button. Move right. Alright. And we go with the D. Close it, and I guess we can replace these. Forward. Back. Left. Come on. Move left. Move right. Okay, the space can remain like that. Let's try it out. We're still moving with the EASD keys. Cool stuff.
And return. You can return to the script view by clicking the script button. We now want our script to list the contents. It is a left and right on the x-axis, containing a variable called input, and tell Godot it is a vector 3, containing the 3 directions the player can move. Left and right on the x-axis, up and down on the y-axis, forward and back on the z-axis. Adding movement
Input X from left to right. Oh, now I make the input variable which store the directions and the input. Okay, we're making this look a bit better. So we're assigning this to vector 0. vector 3. Because it's a 3-dimensional vector. Okay, input text. So the new member of the input object. It will store the axis for move left and right. Guess we're doing it with the y-axis too. Input, okay. Get axis. Move forward and back. There we go. Guess we won't need this.
Like this is a common task in
I've
Godot,
actually learned
so there is a
things
helpful
on
function
this
built in,
because so far I've been only copying.
the getAxis function. This
The
function
more stuff
returns
we do by
-1.0
ourselves,
if the first input
or
event
it
is
will
detected,
stay in our head.
1.0 if the second input event is detected, and 0.0 if neither.
And I see the move forward and move back actually on the z-axis. Yeah, then the y is the vertical. Okay. Let's just fix that.
Either or both events are detected. So, for the line input.x equals input.getAxis,
So press central delta force.
move left, comma, move right. This code sets the x value of our 3D vector 1.0 if neither both of those axes. We are left with a vector 3 that can move our player in 3D space when they push the W, A, S, or D.
Okay. So apply central force input. Okay. Space can remain like that. So a vector will be instead of the vector. Or actually, input stores the vector. How does this work? I actually not really understand it. It might take some time to wrap my head around all of this. What's wrong with this line? Input not declared in the correct current scope.
E keys. Running the level scene now will let you move the player around on the little platform. You may notice the movement is a little floaty. We can rectify this easily.
Oh, that would be
Head
good.
back to the editor. Select the player in the scene tree.
Just a bit, I want to figure this out. What's the problem here? Space input not declared. Oh, because I deleted the space. Where's our space? Okay. That'll be alright, just a sec. Need this on z-axis. Input. Yeah, I just separate the space for now, because I don't know any better solution for this. Okay, now if we tried out... Actually, I just reduced the movement for this a bit. Let's give it like 1800. Does this update in real time? Yeah, movement is sort of floaty.
And look in the inspector.
Yeah.
Under the linear drop-down, find the damp option and set it to 3. Now, the player will lose velocity as they move, to linear damping. The higher this number is, the more forces will dampen.
So it's the way it slows down. Let's find this damp. Linear or angular. What was it? Was it linear or angular?
The higher this number is as they move.
Oh, perhaps the angular would mean a rotational damping. Linear is for movement. Cool. Okay, it's there. Now we wouldn't float. The movement feels a bit sluggish.
To linear damping.
No matter.
The higher this number is, the more forces will dampen. In third-person games, the camera is typically attached to the player and pivots around a point on
Now
them
that would
is
be
relative
nice.
to its
How
parent.
do we do that?
This means if we add a camera 3D as a child of the player, it will move with them, and if the player rotates, so will the camera. Godot does let you ignore relative positioning with a special property called Set as Top Level you can enable on any Node 3D. Top
Wait, what
level,
does this
and if the
do?
player rotates, so will the camera. Godot does let you ignore relative positioning with a special property called Set as Top Level you can enable on any Node 3D. To get the camera setup we want, I am going to use nodes that will act as pivots. Then we can rotate those pivots to control the camera angle with precision. Open the player scene and change the main screen to the 3D view. Select the player root node and we can add our first pivot. Create a new
So we... Wait. We set something to top level. Some of the music, it's that meme music from the some TikTok or YouTube memes. Don't know where it's at. Actually, I just want to search the docs for what top level means. Oh, There's an explanation here. If true, the node will not inherit its transformations from its parents. No transformations are only in global space. Not inherit its transformations from its parents. So basically what this says is that the player will be a child node of the camera, but won't be affected by the transformation of the current. Like when we turn around the camera, player won't be attached to that transformation. At least. Okay, cool. Okay, so back to the player scene. Did we save here? Save open and let's see. Save frequently.
Node 3D by clicking the Create New Node Plus icon at the top of the scene tree and searching for it.
Creating a node.
When the node 3D is created, double-click on it in the scene tree and rename it to Twist Pivot. This is currently a point in 3D space in the middle of our character.
Okay, let's do that.
That the camera can rotate
Node 3D. Okay. Oh. Get through with this. Let's set it to here, this height.
around horizontally. We need a second pivot that will let us tilt our camera up and down.
Twist pivot. So basically that's the center of the camera. That's what the camera will focus on. Twist pivot. Well, according to my understanding.
Add another new node 3D as a child of the twist pivot and rename it to pitch pivot.
Twist.
The node 3D is the symbol.
The twist is for the horizontal rotation, the pitch is for the vertical. Yeah, makes sense. Twist, I want it to make sense. Let's see how it goes down. Pitch, pivot.
Simplest form of 3D node available to us. It just has a transform property and options for visibility, so we can position it in 3D space and rotate it. Perfect for the pivoting action we need. With the pitch pivot selected, create a new camera 3D node as a child. We can now move this camera straight back from the pitch pivot, so it's effectively on a long camera arm rotating around the center of the player.
Hope I don't get stuck in the tutorial, as they say. Yeah. When I started out the stream, like, oops, let me connect my laptop to the power source. I'm just using the laptop for checking my stream status. pivots have a camera.
With the camera 3D selected, look over to the inspector. Under the transform drop-down, set its position's Z value to 3 meters. This is all we need to get the camera centered on the player.
So Z to 3. Where are those transform value? It's 3. Cool. Actually, I want it to be at the back of the player. What should I do? Because this will be facing the player. So let's see. How do I rotate this? Like, I want it to be around 180 degrees. Yeah. Set it to -3. So it will be facing the back of the player. Might be a bit close. Let's see, -5 perhaps. Okay, looks alright.
Save our changes in this scene with Ctrl S.
Of course. Always
Return
save.
to level.scene and delete the old stationary camera 3D node with the delete key. Now, when you run the level, our camera will follow the player as we move around the platform.
Alright. So delete the camera that was here before. Get this player with the camera facing its back. Let's check this out. Right, why am I not moving? It should be with the VASD. Something's not right. Only the jump works. What's up with the script? Move left, move forward, move back. It was working. At some point.
Usually, in third-person games, the center of the screen is an area ahead of the player your view can focus on. With the player character,
Oh, wait up. First I want to figure out what the problem with this. What if we delete this? Now just the input remains. Perhaps the space input overrides the input of the camera. Let's just reload. Move the space input for now. Still can't move around. Wait. This is weird. It worked at some point, but now it doesn't. just find this list of musics before the stream, but some of these are actually quite nice. It wasn't saved, perhaps? It isn't. What could be the issue here? What? Oh, I get it now. We're actually moving, but playing field is so big we just don't see it, right? And actually the movements is inversed because we were facing the camera. Yeah, we're actually moving here, just the movement is mirrored. Okay, let's just fix this. Let the camera back. Right. And let's just rotate the player. Let's do it here. Set it to 180. And now it should be alright. That was trippy. Yeah. It actually just looks weird because of the static camera. Camera is attached to the player. Yeah, but it's working as it should be. There's no issue there.
Lower down. We can fiddle with the position properties of our pivot to achieve that perspective. Go back to the player scene and select the camera 3D. Change the view to preview mode with the Ctrl P hotkey or the preview toggle in the top left of the viewport.
Yeah.
Now we can see the camera's perspective, we can fiddle with the transformations of our pivots. Select the twist pivot in the scene tree, then in the inspector, find the position
So
property
doing this
and
with
set
the
the Y value to 1.0. You'll see the camera's view is 1 meter higher. Now we can orient the pitch pivot so the focus is closer to the floor rather than straight ahead. Find the rotation property in the inspector and set the X value to -10 degrees. This will angle the camera down
this is
towards the
nice.
floor in the middle distance.
So what is it? It's both for the pitch pivot. The pitch pivot is for the rotation. Okay, let's set this. Minus. Wait, we need a review from the camera, right? It can be higher. Let's see, 20. Minus 30. Actually, I don't want it static. How can we make it controlled by the mouse? Want to have a free cam.
This property is closer to the floor and set the X value to
That twist pivot seems high enough. I mean, I already set the center of the camera for the pivots to the players around the height of the neck. Yeah, I'm fine with this.
to -10 degrees. And run the scene to get a feel for this new camera setup. You can opt for over-the-shoulder views, Move the player camera further away and put from the mouse to twist the twist pivot and
Now
pitch
that's
the
what I
pitch
wanted.
pivot. To best listen to mouse input, we should set the mouse mode to captured. Godot has a variety of mouse modes for different situations. By default, our mouse is free, meaning the mouse is both visible and nothing is controlling its position. We want to change the mode to captured, so the mouse is invisible and unable
Check
to...
your project setting keybinds. Okay, what was the... You're just following the tutorial, but thanks for the input either way. You can read input.get last mouse velocity, edit to the var, and use the X for one private and Y for the other. Okay. Get last mouse velocity. Thanks, but I think the tutorial will explain it
leave our game window.
good enough.
Change the main screen back to the script view, and we are going to add some code to another, like the process captured.
Mouse mode. But I'm sure your solution works as good. Perhaps I will try both ways. Input set mouse mode. Mouse captured. I just want to see what the tutorial does first.
However, as it stands, this is awkward for us to test, as we cannot close the window with the mouse anymore. We need to add a way to free the mouse in-game. In the process function, add the following code. As the process function runs every frame, we can listen for when the UI cancel event occurs. This is a built-in event that emits when the escape key is pressed. The if statement checks if a condition is true. If so, the indented code block
Action
will run.
just pressed.
So, if the escape key is pressed, this script changes the mouse mode back to visible.
Okay, this is pretty useful to know. Just add an extra input functionality for the escape key. UI cancel. Yeah. Have to remember this is for the escape key. Set mouse down, mouse mode. Yeah, by default we are setting it to mouse mode captured, so we don't see the mouse by default at the beginning until we press the escape key. Now, you can actually the control key see the documentation for it. Nice, okay. Input mouse mode visible. This is okay. And from now I think we will actually binding action to the mouse.
So the mouse is free. When we run the level scene, you should see the mouse disappear as the window opens, but when you press the escape key, it becomes visible again. Now our mouse is hidden, we can move on to getting information about the direction our mouse is moving. Whenever we move the mouse, an event emits, like when button keys are pressed. Events can be one of many types. Mouse out, but define actions. Define it with the equals symbol or with a colon followed by the equals symbol.
Wait, you define a variable in Godot, you can either define it with the equals symbol or with the colon followed by the equals symbol. When you have the colon, Godot will keep track of what kind of value the variable is holding. Oh, so it means that the variable will change values like dynamically.
When you add the colon, Godot will keep a track of what kind of value the variable is holding. This will give you better code case with a decimal place, which is known as a float value. These variables are going to be responsible for a few things. Mouse sensitivity controls the speed our camera should rotate proportionally to the mouse input. Twist input stores how much our mouse has moved horizontally every frame, and pitch input stores how much our mouse has moved vertically every frame.
Mouse sensitivity.
Now we can add the unhandled input function. Where it is added in the script isn't important, but I'm adding it after the process function. This is the largest block of code we've looked at so far.
Up, I'm typing this. So it's twist input. Use this colon equal symbol. Or page input. Okay, then create a new function for the input of the mouse, I guess.
So let's assess it line by line. Func unhandled input event. This virtual function
Yeah, and we add a condition so it would only trigger the mouse movement capture. So when the hope I get this right. Unhandled input. So we don't handle the mouse input when the mouse isn't captured. If element is input event mouse motion, mouse motion, there. If input dot get mouse move. Yeah, so whether it is captured or not. To check if mouse is moving, we check if the mouse mode is captured with this to condition apply, and we twist the input.
Will run every time an event is detected that has not already been handled by another script.
Alright. And that x multiply by mouse sensitivity. Same thing basically for the y-axis. Hold on, what's this? Identify input not occurred in current scope. It's weird. Oh, because it's capital I. Should be alright now.
There are a variety of events that the event parameter can be. We could receive an input event mouse button, an input event joypad button, an input event mouse motion, and more. Different events hold different data, so we will need to check what kind of event the function has received. If event is input event mouse motion. If the event is mouse motion, we will always be updated when the player moves the mouse around. These events tell us how far the mouse has moved from its last position. If input.getMouseMode is captured. Checking if the mouse mode is captured means when we press escape to free our mouse from the game, our mouse inputs will be ignored and the camera will no longer move around. This is useful for preventing camera movement when the mouse is free, like when the player opens a menu. Twist input equals negative event.relative.x times mouse sensitivity, and the same for pitch input and event.relative.y. Now we set the values for the twist input and pitch input variables we defined at the top of the script. Event.relative stores how far the mouse motion is relative to its last recorded position. It has an x value storing horizontal change and a y value storing vertical changes. We store the negative version of this value, so when we rotate the camera, it rotates in the same direction the mouse is moving. Finally, we multiply the event's relative value by the mouse sensitivity. The lower the mouse sensitivity is, the slower our camera will rotate, and the higher it is, the faster the camera will rotate.
I want it to be fast.
Now we have values for how far our mouse is moving, we can focus on applying these changes to our camera, and taking advantage of those pivots we created earlier. Applying rotations to 3D objects is a complicated process, with a large number of ways of representing 3D rotations on 3D objects. To avoid any confusion about how rotations should be applied to our nodes, I like having separate pivots dedicated to rotating horizontally and vertically. Return to the process function and add the following line of code at the end. If you did not rename the node 3D to twist pivot, this line of code will raise an error when the code runs.
We're controlling the twist pivot now. Oh yeah, we will rotate that. The $sign twist pivot. So that's how we refer to nodes that have been already declared. Rotate. Y. Twist pivot. Twist input. Okay, I think I know how this continues on. Let's see, $sign pitch pivot. Pitch. And we rotate this according to the x-axis. Uh-oh, it's frozen. Not responding. What if we restart? I guess we aren't finished with the code.
Ensure it's named correctly. Your scene tree should look like mine does. Our player script has a child node called twist pivot, so the dollar symbol lets us access that node with the given name. When you have access to a node like this, you can do many things. Save it to a variable, access its properties, call its functions, like queue-free to delete it. 3D nodes like functions for altering their 3D nodes have functions for altering their transform property. We are going to use those rotate functions to rotate our camera around the pivots. The rotate Y function rotates the camera around the Y axis by the number of radians given as a parameter. Radians are a unit for measuring angles like degrees, where instead of a complete rotation being represented by 360 degrees, it's represented twist pivot left and right according to how far the mouse has moved horizontally. See that when we move the mouse, the camera rotates to the level scene and run the
That's supposed to work.
game. We should see that when we move the mouse, the camera rotates, or when run 5 or the big play button will let you select the current scene as the main scene of your game. Always launch that selected scene. If you want to alter the main scene later, we'll always launch that selected scene. If you want to alter the main scene later on, you can access it in project settings. We have mouse motion working horizontally, but there is a complication if we add vertical mouse motion. If you spin the...
Oh, so that's why it doesn't work. Just delete this. So it should be working like this now. Actually, let's check out the project settings. Yeah, this is the main scene. Hey, it's moving. Only that our character doesn't rotate. It's a bit weird. I might do this part after. Just set our character to rotate at least. And now I pressed escape and stop capturing the mouse input. Okay, let's get into
the camera all the way up or down. Eventually the camera will turn upside down. To avoid this, we need to limit how much the pitch pivot can rotate. Add these extra lines to the process function.
Yeah, except we will go round and round with them.
As with the twist pivot, this path will cause a crash if the second pivot is not called pitch pivot. If you want to find out what a path should be, Godot can generate it for you. In the scene tree, right-click on the node you want a path to, and select it. But this path to the process function. as with the twist pivot, this path will cause a crash if the second pivot is not called a pitch pivot. If you want to find out what a path should be, Godot can generate it for you. In the scene tree, right-click on the node you want a path to, and select the Copy Node Path option. For this code block, we start in the same way as the twist pivot. We get access to the pitch pivot and call it rotate X.
I guess we can go back and redo this and extend it with twist pivot. Wait, we changed some things around here. Come on, too many windows. Guess I just close Blender now. Rotate Y with twist input.
Function, and pass in the pitch input holding the mouse's vertical motion.
I not quite get it. Why did we? Oh, never mind. I thought we changed the rotate Y with rotate X. Okay. Let's just get this. This then using $sign. This pivot, which pivot, rotation, .x, and we clamp it. That means that we set some values, so it wouldn't go over the minimum value and the maximum value. Rotation X. Oh, yeah. And this thing is in already else. Is this working right now?
After we have rotated the pivot around the x-axis, we need to limit how far the pivot can rotate. The rotation property stores the rotation of the node
That's
in
set
radians
alright.
for the x, y, and z axis. We access its
it does
x
it.
value and set it to the result of the clamp function. Clamp is a particularly useful built-in function that takes
Actually, I
three
think I
parameters.
just smoothen these
The
values.
input you want to modify,
Right.
the
yeah.
minimum possible value you want that input to have, and the maximum possible value you want that input to have. Whenever the input goes below the lowest value we want, clamp returns our lower boundary, and if our input goes above the higher boundary, clamp returns the higher boundary. This makes it a helpful function for keeping a value between boundaries. In our case, we keep the rotation on the x-axis less than 0.5 radians and above negative 0.5 radians. This makes it so our player cannot tilt the camera above or below about 30 degrees.
Which is which?
Finally, we set the twist input and
So
pitch
to try
input
out how
to
these
0.
values work.
If we did not, the camera would continuously move in the last direction you moved the mouse. This way, the camera moves as far as the mouse moved, then stops. And with that, you can run the scene and look around with the mouse. But there are a few changes we can make to our code to make it easier to read. You will notice that the arguments for the clamp function are spread out over multiple lines. Because they are indented, Godot understands that they are all parameters, but it needs this much space because the definition of pitch pivot is so long. We can get around these long paths by assigning the nodes to shorter variable names. At the top of the script, where the three variables for pitch input and the like are defined, add the following. Using the @ symbol in this way is a new syntax specific to Godot 4.
Convenient to just keep
It is the
mouse
first character
captured.
for a specific kind of keyword called an annotation. The
Wait. Event is introduction. How do we set the? Wait, there was a function for this. Input is action just pressed. Ah, yeah. Set a way for the mouse to be captured again. I just copy this and find another key for capturing the mouse. UI accept. Guess that will be the other key. We set it to capture back again. So now that we run the game, okay, escape, enter, escape. We don't control the mouse anymore. Oh, I'm in the camera with the mouse. Enter, we're back. Yeah. It's pretty useful to try to do stuff on your own as well. I guess I'm just copying code and changing some things around it. I actually want the camera to be a bit shallower because I don't want it to run into the ground. Yeah. Okay. And what I want to try again is to rotate the guy with the camera. Player. Pivot, rotate, right, input. Can we set it to include the player as well? Wait, how do we get the player? Let's see if we can get some help from the autocomplete. Animation player. Rename, move out, duplicate. I want to move the whole thing, like rotate it all at once. Maybe it will look too static. I think this one thing I can try to do by myself. Capture the twist pivot. It would make sense to have the whole player move. It's 1 minute. Oh wait, swan go. We have to set things separately. It makes sense that the twist pivot and which pivot would move like that. Or the whole solution to the problem is to make the pitch pivot and the twist pivot be at the under the child of the pivots. I mean the meshes as the child of the pivots. Now we don't see anything. Okay, that causes problems. What is it? Node has no shape. Collision shape. Okay, let's change this back. Then go with a mesh. Now it's under the camera. How does this look? Still crappy. But now there's no warning and such. I think we are running the wrong scene again. Okay, it's a bit weird. Camera rotates and the player with it. Also the player the player rotates vertically as well. Okay, this looks silly. They just make it back. This is not the way. 1 radian equals 180 degrees. You want to rotate the interface, just self-rotate. Not self-rotate. Okay, but that will be the object. Rotate the interface, just self-rotate. Not sure how the code would look like. Oh, self. It's an object. Oh, I think I get it now. So instead of twist pivot, we go with self. Wrong scene again. It's kind of working. Thanks, dude. What happened with the collision? Just restart. think I pressed something with the... Probably changing direction. I think I missed something. Don't think we're moving as we should. Did I overwrite something? Let's see if I make this. Okay. That's weird. Now we plug back into those keys. Can kind of jump around. Seems alright. Right, just go with self-rotate. Let's restart it again. Weird. Probably it's me that did something wrong. For now I just keep it like it was in the tutorial.
The annotation onReady indicates that the variable is related to a node in the scene tree. Just before the script's ready function is called, the onReady variables are evaluated. As a result, we can use the @ symbol in the... You will notice that the arguments for the clamp function are spread out over multiple lines. Because they are indented, Godot understands that they are all parameters, but it needs this much space because the definition of pitch pivot is so long. We can get around these long paths.
Oh yeah, I get it now, because this is how we write the reference to the pitch pivot, because pitch pivot is a member of twist pivot. Yeah. So this would be self, this would be referenced with a $sign in the name. And if we would want to reference the camera, it would be another layer deeper. Okay. Another thing.
By assigning the nodes to shorter variable names. At the top of the script, where the 3 variables for pitch input and the like are defined, add the following.
Make some variables.
Using the @ symbol in this way is a new syntax specific to Godot 4. It is the first character for a specific kind of keyword called an annotation. The annotation of a specific kind of keyword called an annotation.
First major hurdle when trying to write a new script is the introduction of annotations. Previously a new symbol. Annotation replaces a bunch of keywords which help group the language better, improve code completion and hinting. We also have a distinct syntax highlight in orange to help them better stand out. Export onReady.
annotation. The annotation onReady
That's
indicates that the variable is related to a node in the scene tree. Just before the
onReady.
script's ready function is called, the onReady
Or
variables
this.
are evaluated. As a result, we can use these variables in our ready function. There are a host of other annotations that you can explore thanks to code
Now
completion.
we can reference this.
Once you type the @ symbol into the code editor, a drop-down will reveal the list of all the available annotations starting with the @ symbol. Now we have two variables referring to our pivots, we can
Alright.
replace the long paths in our camera rotation.
Okay, let's just check what this actually means. Mark the following property as assigned when the node is ready. Values for these properties are not assigned immediately when the node is initialized. And instead competence stored right before node.ready. What does it mean that a node is ready? Perhaps when we don't render it right away, we are creating it later or some such. Okay. Which pivot? And now we set this here, the music's gone again. Why does it keep doing this? I'm sure there is some way to cancel this thing to not pause when the tab's not active or something like that. It's not prettier. Does it work the same way? It's frozen. That sucks.
Annotation code blocks
I
with those new names.
brought
Our clamp
something
function
wrong.
currently handles its maximum and minimum angles for the camera in radians, but this is not easy for most people, with degrees
Yeah, this is
being
how
a
I wrote
more
it.
common unit. Godot has built-in functions for converting values from degrees to radians and vice versa. The deg to rad function converts a parameter from degrees into radians. The rad to deg function converts a parameter from radians into degrees. We can replace the negative and positive 0.5 boundary with
Yeah,
the
that will
deg
be
to
more
rad function,
understandable to just
and a
use
value in degrees as a parameter. Replace the clamp function with the following.
Minus 30 to 30. Okay, but first, what caused the game to go haywire after creating these variables here? Try to run again. Okay, not sure what went wrong, now it's fine. So, back to red. Maybe go down to 90. Tag to red. Wait, what they wrote? Minus 30 to 30. Okay. Where does this go? Have to play around the values a bit. Okay, that's not right. It's not sure what the values look like. What is the 180 exactly? I think I saved. Okay, working again. Okay, let's just go with the values he suggested in the guide. Excellent. How does it go now? Yeah. So do we want less or more than -30? Yeah, 60 is too much. Okay, we reduce this to 20 and this, let's say 60. Let's see if it's better now. Looks okay-ish.
The camera moves around with the mouse, but if you move the player, you will quickly find the player does not move in the direction the camera is facing.
Oh.
When the
So
W
this
key is
shit as
pressed, the player always moves in the global forward direction, which is -Z. To fix this,
Yeah,
instead
this
of
would be
moving the
useful
player
to do.
globally forward when the W key is pressed, we need to move the player forward from the camera's perspective.
From
3D objects in Godot have a transform property. This stores two things: the object's position in 3D space, and the object's basis, which tells us its rotation and scale. By storing the way we want to move the player as a vector 3, we can combine it with the camera's basis to rotate the force to the same way as the camera. Handling basis and 3D rotations is a complex process. Thankfully, the actual steps we need to take in code are simple. Our twist pivot is rotated the same way as the camera on the y-axis, so we can use its basis.
And first is pivot basis.
To rotate a vector 3 to be the same as a basis, you multiply the basis by the vector 3. So, we can replace the apply force function in the process function with the following line.
Telescope. Let's pivot basis. Okay. I think everything is true. Let's hear the explanation again.
We can use it rotated the same way is a complex process. Thankfully, the actual steps we need to take in code are simple. Our twist pivot is rotated the same way as the camera on the y-axis, so we can use its basis. To rotate a vector 3 to be the same as a basis, you multiply the basis by the vector 3. So, we can replace the apply force function in the process function with the following line. When you multiply a basis and a vector 3, the vector's forward direction is aligned with the rotation of the basis.
Yeah, I think I just do that. So apply center force. Basically what the basis. Basically, direct access to the 3x3 basis of the transform property. Let's see if it does what it's meant to do. Right. Okay. Cool. I'm moving according to the camera, except the player doesn't turn. Not sure if this guide will solve that. It's actually the end.
So our vector that points globally forwards when W is pressed will point forwards from the twist pivot's perspective. And with that, our player can look around and move relative to their orientation. Ram again. Thank you very much for watching. You've now finished the first 3 chapters of my topic.
Yeah, basically this is it. So the tutorial I did was from Bramble channel. Yeah. Now to figure out how I can rotate my player without crushing the whole thing. Basically rotate. If I self rotate, or will this rotate? Oh, pivot. It's floating. Self-rotating would be cool if the wouldn't cause the player to float for some reason. Just the rotation itself works. Let's see if there's something in the comments about this. If you're using character mesh that isn't a capsule, then you will be able to see that the character does not rotate over the camera direction as the tutorial stands. Abstracting the row numbers to various good code practice, creating the move speed variable, for instance. Adding a spring arm as a parent to the camera, but still child pivot in the case is also good practice. Okay, hold on. Need to take a toilet break. I'll be back. So basically self-rotate causes the player to float. I think it overrides the other inputs. Not sure how to do about this. So what does this comment say? Infiltration should be normalized to being able to travel faster than in diagonal directions, whereas the inputs are added together. As the rigid body is being used, action line should be handled in physics process. Unity was a bit easier to begin with, but I didn't actually do anything, just edit stuff and that's that. Or it wasn't Unity, it was Unreal. Start of the stream I showed some basic stuff in that. Does this comment actually says how to solve this? Which basically list with issues. Okay, I just scrapped it again. Just build. Okay, I think I have to restart. It's faster in the diagonal directions. No, it's okay, let's normalize the input. Seems to be easy. Is this the vector which is normalized? Okay. Let's check if it's still going faster. So let's compare it. This is normalized. Okay. Remove this line, this part. Is it normalized now? By default. I'm not really seeing the differences. Let's rerun. So right now it shouldn't be normalized. Is it faster? Might be. Just want to make sure I'm setting up the right things. should be on the vector. So save. It shouldn't be faster anymore. Just want to make sure this is how it works. It doesn't seem right. It still seems to be faster diagonally. Did I set it in the wrong direction or wrong vector? So documentation, vector 3 normalized returns the result of scaling the vector to unit length. Close the script. Oh no, just the player scene. Okay. Just the zero vector with all components set to 0. Yeah, this is by default. This is input vector. What if we set it to normalized here? Not when it's 0. Just to be sure I rerun it. Okay. Can only see if it's actually faster or not in the closer to the edges. Yeah. It is slower now.
Cool.
Also, I have to figure out how this. The gravity is kind of slow. Should make the thing more heavy. Let's see how we can change that. Is there a gravity option? Gravity scale? If we... Gravity scale. This is multiplied by the global 3D gravity setting from project, which is produce rigidity 3D's gravity. For example, the value of 1 will be normal gravity, 2 will be double. Gravity 8 times. Oh, now I can jump. Too heavy. Okay, let's set it to 3 then. Yeah, now it's heavy. Should make the jump have more force. Let's see. 6,000. Let's go with that. Also the thing about that this isn't a one-time force. Let's go. There's all kinds of music in this playlist now with from the Chinese. I'm just fiddling with the values now. So maybe better to add some color to the main scene's mesh. And color it straight up. Geometry. Global illumination, visibility range. Static voxel. Down here, yeah. It only has an upper side. Now it's Christmas musical, so all kinds of. Try to find a decent music provider for next time. At least have the mood to be consistent for it. Okay. Basically, I think this is how far this stream can go. Need to get some food. But I will be back shortly. I think I'll just do some gaming after. That's it for today's Gamedev stream. Thanks for joining in, thanks for listening.